This is chapter 10, number 42. We have a sphere that's rotating. The diameter of the sphere is 0.72 meters, so the radius is 0.36 meters. The torque that's applied on the sphere is 10.8 meter newtons. It starts at rest, and the angle is 180 revolutions. It makes 100 revolutions, which is the same thing as 1130 radians. So the time it takes to do that, to accelerate from rest, is 15 seconds. Question is, what's the mass of the sphere? This is kind of a if-only game that we're playing. First of all, we need a formula for the mass. And a formula that has mass in it is the moment of inertia. Moment of inertia for a sphere is 2/5 mr squared. So we can for m gives us 5 over 2r squared Well, we know R is 0.36 meters. Here's the if only game. If only we knew what I equals, what the moment of inertia equals. Well, the formula that I equals well, let's put it this way. Let's start by saying that there's another formula that has I in it. Torque. Torque, moment of inertia times angular acceleration. So for I, we get torque for acceleration. Now, the torque we know, it's 10 meter newtons. Angular acceleration, however, we still don't know. It's the if only game again. If only we knew what the angular acceleration is. Well, angular acceleration we could say is the change in angular velocity over time. But that doesn't help us because we don't really know the change in angular velocity, although we do know the time period. But what uses the angle and time and acceleration? And that's where we use this formula. Whoops. It's not Vt, it's omega t plus 1/2 alpha t squared. Now, if we solve for alpha, we get tangent theta to 0 because the initial angular velocity is 0. So solving for alpha, we get 2 theta over t squared. We plug that in, and for alpha we get alpha equals 10.05309 radians per second squared. Okay, now that we know that, we could plug that in here. Torque over alpha, plug that in, and the moment of inertia equals 1.074295866 kilogram meter squared. Now that we know the moment of inertia, we can plug that in here, and the mass turns out to be 20.72329988 kilograms. Now, in all of these, number 42, it looks like they tell us it's 7.72 meters. It's two significant figures. So our final answer will be in two significant figures. The mass equals 20 kilograms. And you're done.